Hello guys, this is LeetCode question number 435 non-overlapping intervals. So I hope you are doing extremely great and today we'll be discussing this question. So here we have been given an array of intervals which is called intervals where intervals I is start comma end. So this basically means this interval is starting from start I and ending till end I and ending at end I. And we have to return the minimum number of intervals we have to remove to make the rest of the intervals non-overlapping. So let's understand this. So we have various intervals and they might be overlapping with each other. For example, 1 comma 3 and 2 comma 5, they are overlapping, whereas 1 comma 3 and 3 comma 4, this is not overlapping because 3 and 3 they aren't considered overlapping here in this question. Also 1 comma 3 and 5 comma 6, they are not overlapping because there is a clear difference of because there is a clear gap between them. Also 1 comma 6 and 3 comma 4, they are completely overlapping. So we have to remove the minimum number of intervals from this group to make the rest of them non-overlapping. Let's take the example number 1. We have 1 comma 2, 2 comma 3, 3 comma 4 and 1 comma 3. Let's make the diagram first to understand it. Okay, so we have 1 comma 2 and then 2 comma 3, 3 comma 4 and 1 2 3. We have these four intervals. Now we have to remove the minimum number of them to make the others non-overlapping. Here, according to this question, this interval and this interval, they are not overlapping. Okay, let's keep that in our minds. So let's try to choose some intervals and we'll just remove them. Okay, let's try to remove this interval and this interval. Now the rest of them are non-overlapping, correct? Because 1 2 and 3 4, they are not overlapping. So one candidate is 2 because I can remove these two. Similarly, I can remove these 3 also because this will be the only interval which will be of course non-overlapping with any other, because any other intervals are absent here. This is also one of the answers, but it is not the minimum one clearly. But there is one more thing that I can do. I can just remove 1 comma 3. As I remove this, the other intervals, they are not overlapping with each other at all. 1 comma 2 is not overlapping with 2 comma 3. This is not overlapping with 3 comma 4, and the all of these three are not overlapping with each other. So we have found our minimum answer, which is 1, and so the answer is given as here. Similarly, for 1 comma 2, let's take the example for the second one. We have 1 2 1 2 and oh okay, so we have 1 2 3 times. Okay, so if we are given this, I can just remove any two of them to get the only third one, which is of course non-overlapping. So answer is 2. And in example 3, we have 1 2 and we have 2 3. These two intervals aren't overlapping with each other, so the answer will be 0 because we don't have to delete any of the intervals. Okay, now how can we solve this? Okay, so one approach that comes to my mind is I can maybe approach a greedy algorithm, where I will choose the ones which are the furthest left. In other words, those intervals which have their end point as least. Like in example 1, the interval having the least end point is 1 comma 2, which is the leftmost out of all the intervals. So I can choose that so that I get space to accommodate other intervals in the rest of the gap. So it is optimal to choose the one which has the furthest left, which has the leftmost end point first. So let's choose maybe 1 comma 2. Then I can choose any other interval. Let's say I can choose this 2 comma 3. Okay, oh, forget this example one. Let's make a diagram instead, and I'm going to sort all these intervals in terms of endpoint, in terms of increasing endpoints, non-decreasing endpoints. So let's do that. We have this. One interval might be like this also, right? This can also be one of the possibilities. These two intervals having the same endpoints, this is also the case like this. Let's get little unique, this and this. Okay, This is one of the conditions. Great. Now I can maybe choose I can choose, let's say I am starting from here. Also, as you can observe here, all these intervals are sorted in the terms of their ending points, not the starting points but the ending points, because we are using the greedy approach where I am choosing the leftmost interval. Then I am accommodating the, then I am ensuring that all the other intervals can be picked, because the one that I have chosen if the leftmost possible. Okay, so I have picked this. Oh, sorry. So I have picked this. If, as I have picked this is impossible to pick. Also, you might think that if I am picking this, it might get optimal in future, but that cannot be the case. Why? Because if I am picking this, I might as well pick the previous one, because it even has a better ending point. It even has a more left ending point. So it is optimal to pick this rather than this. So this greedy approach actually works. So I have just proved that. Okay, I have picked this. I cannot take this I cannot take, because the starting point is not more than or equal to the ending point of this one. Okay, also we have to keep track of the furthest right, that for any interval it has to follow that the starting point for the interval to be more than the current ending point, current furthest right. So at this moment we have this as the furthest right. Okay, let's name it fr at this moment. Okay, so currently fr is this interval has left point lesser than fr, so rejected, rejected. This is also rejected. This we can take. Why? Because the starting point is more than or equal to fr. In other words, I can choose this, I can choose this, and I can choose this at the same time. Why? Because both of them don't have the common, because both of them are not overlapping. And why they aren't overlapping? Because the starting point of the second interval is more than or equal to the rightmost part of the previous intervals. So these both can be picked together. Similarly, this, oh, okay, now as I have reached here, my fr becomes this. My fr becomes this. Okay, very good. Now I am moving ahead. This interval I can again pick. Why? Because the starting point is more than or equal to fr. Very nice. I can now move this fr to here. Great. Now the answer is I can pick this, I can pick this and this. So the answer is 3 at this moment. Okay, also we are maintaining a count. Initially it's 3. Okay, now this I am moving here. It cannot be taken because the rightmost is not lesser than the starting, so rejected. This can also be picked because the starting is more than or equal to the fr, so it can also be picked. Count becomes 4. Now the ones that we have picked are, let's mark them with blue. Now the ones that I have picked are this one. I can pick this one, and this one. So the answer will be all the intervals which are not these. So it will be n minus count. So the answer will be n minus count. Why? Because we are picking these intervals for the optimal arrangement, to ensure that we are picking the most amount of intervals possible without them being overlapped. So this maximizes the amount of non-overlapping intervals, thus minimizing the intervals that need to be removed. Therefore the answer will be n minus count. So let's implement it very quickly. So for the implementation, I am creating a data structure. I am creating a structure called interval, following the oops. And integer end. Each interval has a start point and the end point. Okay, great. Now the parameterized constructor for this. Start will be okay. Yep, we have made it. Now let's make a vector of all the intervals. Now we have to make a collection of, now we have to make a list of all the intervals. So for that, let's create a array called intervals. Now iterating through all the vector pairs of intervals. Also let's name it int. Let's name it in. Emplace back. Now as I'm using emplace back, I can also use this syntax which I'm gonna use right now. So it is interval 0 comma interval 1, and now this will not create a different object which has to be pushed inside this vector. It will just do it in situ. Okay, we have now done it. Now we have to sort these on the basis of the endpoints. So for that I will sort them with a custom comparator. So let's see how it's gonna be done. Intervals dot begin, intervals dot end. Also I am essentially passing a lambda function here, which will be the custom comparator function for this sort function. Also my mom bought some sandwiches for me, so shout out to her as well. Now this lambda function returns a bool, and the comparison will be return a dot end less than b dot end. Yep, so our sort function is now complete. Okay, now the sort function is complete. So let's first define some variables. Okay, n is the size of intervals. Count good. Let's name it count good intervals, which will be the intervals that we can pick without getting them overlapped. Now iterating through the intervals one by one. Also we have to keep track of the rightmost occurrence for till we have reached the any int, right? So it will be named integer for the most right. In the tutorial I named it fr, so I am gonna do that same here also. So it will be named fr, also initializing it with -1. Also in this question the constants say that the start point can be at as less as -5 into 10 raised to the power 4. So this has to be initialized with a value lesser than that. So I can minus 1 e raised to the power 6. I can initialize it with this. Now I can start my traversal. Dot start is more than or equal to fr. If it is more than or equal to fr, I can count that interval in. So thus increasing this value and updating my fr with interval dot end. Yep, that's pretty much it. And in the end just return the difference n minus count good intervals. Yep, that's it. Now let's try to run this code. Before running, let's just check for any potential bugs. Structure is implemented correctly. Erase overlap intervals. Okay, in. Looks okay. Okay, sorted also correctly. Fr is initialized correctly. N is also correct. Now count good intervals. Yes, this is also good. Now iterating through all the intervals. If interval.start is more than fr, count good intervals plus plus. Fr is now end. Now end minus. Okay, looks okay to me. Let's run it. Yep, all the test cases got accepted. Let's submit it now. It should ideally work, but let's see if it does. Yep, it got accepted. So let's discuss the time complexity now. Here I am iterating through all the intervals. This is linear big O of n. Now I am sorting this n log n. This is also n log. This is also linear. So overall time complexity will be big O of n log n, and the space complexity used, that will be big O of n. That will be linear. So yeah, that was pretty much it. So I hope you like the algorithm. I hope you like the approach that I used, and please drop down any comment or any feedback you have, or some new thoughts, any new approach you have in your mind, or any query regarding anything like the syntax, what principles I used, anything. I would love to read them and reply to them. So thank you and bye.